Hi guys, welcome back to my channel. This is Grishma MS, currently studying in Sri Venkateshwara College of Engineering. Today is my subject about ADA and the topic is Kruskal's algorithm. So let's start the topic without any delay. Introduction to Kruskal's algorithm. Kruskal's algorithm is a popular method for finding the minimum spanning tree of weighted graph. It has developed by Joseph Kruskal in 1956 and is widely used in network design. The algorithm operates by selecting edges in increasing order of weight until it spans all vertices. In this slide, I have explained what is Kruskal's and why it is used and who have developed it and in which year. So let's go to next. Understanding minimum spanning tree. A minimum spanning tree connects all vertices in a graph with the least total edge weight. It ensures that there are no cycles and that all vertices are included. The minimum spanning tree has only many particles applications such as network routing and circuit design. We can see in the image that minimum spanning tree. Select the edges connected by undirected graph. From the tree that connects all the vertices, minimize the total edges weight and spanning tree. We have to take the connections in the spanning tree by taking minimum length. Later, I'm going to explain all about it by giving an example detailing. Graph terminology. A graph consists of vertices, nodes, and edges connected between nodes. Weighted edges are used to represent cost, distance, or other materials associated with connections. Understanding the terminology is a crucial form of implicating the Kruskal's algorithm effectively. Algorithm overview. Kruskal's algorithm is greedy algorithm that builds minimum spanning tree incrementally. It adds the smallest edges that does not form a cycle with the edges already including in the tree. The process of continues until the spanning tree includes all vertices the graph. So here we are explaining how the Kruskal's algorithm we have to draw a graph by giving an example in the image. So let's see what is minimum spanning tree. So minimum spanning tree is a subgraph. A subgraph contains all vertices and connected and no cycle should form in that graph. Why do we call it a minimum spanning tree? The sum of the weight of the edges should be the minimum. Whenever we connect all the edges, it should be lesser and it should not form a circle. So here I have written an example and the modified graph. So let's take a graph like A, B, C, D, E and F, G and we will start valuing it. Like A to B is 2, B to C is 7 and A to D is 4, D to E is 2, F to B is 8, B to G is 4, F to J is 1. We have to convert to modified graph. How we are going to convert it to modified graph? Like we have to take the distance minimum. So when we join A to B, it is 2. So the minimum value what it's traveling, it's 2. We can connect it. Next B to D. B to D we have to take 1. Why can't we take 4? Because 4 is maximum. So 1 is the minimum. Next D to E. D to E we have taken 2. And if we come what A to F, we can't take A to F because it will form a chain and also it is the maximum number like 5. So we can take F to G where it forms only 1 and the chain is not linked. And next we E to C. E to C we cannot take because it will form a chain. So we have to take G to C whereas 6. Like this, if we connect, the minimum weight of this spanning tree is 16 as I have written in the side. So this is a modified graph. The steps Kruskal's algorithm. As I explained in the previous example, here it is the steps how we implement it in a program for running the Kruskal's algorithm. Involves sorting all edges in non-decreasing order based on their weights. Step 2. Adds edges by one, checking the cycle using union find data structure. The algorithm treatments when the number of edges in the spanning tree is one less than the number of vertices. Cycle detection. So we have to detect where the cycle forms and we have to remove the connection between that. So as I show in the image, let me explain it. Cycle detection is an essential to ensure that the spanning tree remains valid. The union find structure helps quickly to determine in adding an edge would form a cycle. If two vertices share the same parent, adding the edges would create a cycle and it discarded. So here they have explained if two vertices join and if it form a circle, it will start deleting the node which has formed the circle at the last. Adding edges to the spanning tree. After sorting, edges are proceeded in order, starting with the smallest. Each edge is added to spanning tree unless it creates a circle. This greedy approach that we always choose to least expensive options available. So let's see an example to the Kruskal's law. So consider a graph with six vertices and weights edges between them. Applying Kruskal's algorithm, we sort the edges and being adding them the minimum spanning tree. The final tree connects all the vertices with the minimum total weight. As I said in the last example, here I have given a now with the image an example that we have to start connecting the graph, but it should be the minimum spanning tree. And finally, we get an answer of cost of 11. Visualization of an algorithm. So what is the visualization of an algorithm? Can help in understanding the step-by-step process, how it is forming, and diagrams can illustrate the selections of edges and the formation of minimum spanning tree. So the diagram will help us where to form a minimum spanning tree and the which edges are it's connecting. This adds the grasping concept like cycle detecting in component union. So I have given a diagram where it is there in two shades, green and red, and how it's forming in a tree with the minimum spanning tree. Applications of Kruskal's algorithm. What are the applications of Kruskal algorithm widely used in network design? So this Kruskal's algorithm is used for network design such as telecommunications and computer networks. As we see in daily lives, it can also optimize transaction networks by minimizing road length or cost. Other applications include clustering, where it will help in minimize distance between clustered points. So let us compare the Kruskal's algorithm with Prim's algorithm. Both are same, like both Prim's and Kruskal's algorithm find minimum spanning tree, but use different strategies. They use different strategies, but both are same. Like we have to find the minimum spanning tree. So Prim's algorithm grows the tree from the starting vertex while Kruskal's works globally by the edge selection. The choice between the algorithm often depends on the specific properties of the graph in a question. What are the advantages of Kruskal's algorithm? When we're using this Kruskal's algorithm better than the Prince algorithm, so what we can gain from this? It's a particularly efficient for space graphs where the numbers of edges is much less than the number of vertical squared. The algorithm is soft, sorry, starting forward and implement, especially with the help of union find structure. Its greedy nature makes it easy to understand, apply various problems. So this Kruskal's algorithm is very easy to understand and also apply in the problems which we faces when we are using it in network connections. So pseudocode of Kruskal's algorithm. What is a pseudocode of Kruskal's algorithm? It's an outline main step including the edge shortage of cycle detection, and it provides a cycle framework with the implementing the algorithm in various programming languages. Understanding the pseudocode helps in translating logical accurate in the code. So the image I have given in the slide about the pseudocode, how it runs and what are we are going to use when here it should convert into pseudocode. Real world example. So here I have given a real world example. A telecommunication communication company uses Kruskal's algorithm to design its network infrastructures. By minimizing the total length of cables required, they reduces the installations cost. This particular example highlights the algorithm efficiency, effectiveness, and real world applications. So finally, let's see the conclusion of Kruskal's algorithm. Kruskal's algorithm is the powerful tool for finding minimum spanning tree of weighted graph. Its greedy approach to effective make it suitable of various applications. And understanding this algorithm enriches the knowledge graph theorem of the optimized techniques. So this is the conclusion of Kruskal's algorithm. Okay. I hope so this video helps you guys. So please like, share and subscribe. Thank you for watching this video.